Let me show you this circle again, the EBM circle, which was composed of these five steps: ask, acquire, appraise, act, and assess. And so that you will have an image at which level of the course we are now. So today we will discuss the appraisal, how to appraise a scientific evidence publication. There are two kinds of validity: internal versus external validity. Today we are going to discuss internal validity. That means, did the study measure what it said it would, what it was intending to measure? Is it really trustable? Is it really measuring what we wanted to measure? Of course, after proving that your evidence is internally valid, you should also look for external validity. That means, are the results applicable to your own settings? So among the internal validity, we have the bias issue. The bias issue, if you click on the links here, the catalog of bias, you will see tens of different types of bias. Or under the Cochrane web page, also you will find nice resources. But I have brought you here 6 or 7 different biases, which I believe are very important. What is bias, first of all? A bias is a systematic error or deviation from the truth in result of inferences. So there are some inferences, there are some factors affecting your results, your values, and this is a system leads to not a random error. It's not randomly occurring, it is a systematic error, and it leads to a deviation from the truth. That we don't want, of course, and we have to be very careful whenever we read a paper, a manuscript. We should be careful when, and check whether there are some sources of bias or not. Among the most common biases, we have the selection bias. If you have made incorrect selection, that is, your groups, if you have different groups, are not randomly composed. One group composing of elderly people, let's say, the other one younger people. That's not comparable. And one group males, another group more females, that also not. So the baseline characteristics, including sometimes some other, depending on your study, it may be a blood pressure, which is very important. Any confounder, any possible source of inference should be taken care of, and the selection should be as random as possible. Then we have the allocation bias. When we are conducting randomized controlled trials or experimental studies, we have this randomization. And the randomization, how you allocate your participants into the different groups, that's also very important. It must be also preferably blinded, double blind, and also concealed allocation, so that the participants, they are not aware, or the researchers, they are not aware which participant is in which group. The third is the adherence or performance bias, because if you have different groups, and in one group there are more people adhering to the therapy or to the protocol, that means in that group you may observe some different results compared to the other group. So we have to be also careful when looking whether there is adherence equal in the different groups. Here we have discussed before, and we will also do some practice about the intention to treat analysis. Detection bias, that means your measurements, your devices, how you measure. If you are using a questionnaire, the questionnaire, whether it is standardized or not. If you are measuring something in the blood, in the laboratory, whether your devices are calibrated and they're really measuring whatever they measure correctly. That is also important. If there is a detection bias, you cannot trust your results. One type of bias we know, but we usually don't take care so much, is the Hawthorne effect. That is, when a person, your participants of the study, usually are different than those who rejected to take part in the study. And once they have been enrolled, they are selected as participants, they change their behaviors. They are not anymore acting as they would if they were not in the study. So this we have to be also careful of. But unfortunately, this is the reality. If a human being, even non-humans, even the electrons, the physics, they discussed the Hawthorne effect. So if somebody is observed, his behaviors unfortunately are changing. Important is that we are aware of that and we take care of this. Attrition bias is related with withdrawal. If you have two different groups, and in one group you have more people who don't comply with the protocol and they leave the study, it is very important how you analyze. Here we have mentioned this intention to treat analysis. Intention to treat, I have to explain it in my other presentations. You have to refer to that, or you may look for other references. Intention to treat, or the attrition bias, withdrawal, unequal numbers of withdrawals in the different groups. That is also very important, because if in one group many people are withdrawn, that raises some questions. Did they leave the study because they didn't benefit? Maybe yes. Maybe they did not benefit from the study. That's why they left. What would happen if they have remained, if they have stayed in the study? So therefore, the attrition bias is also very important. Lastly, the publication bias, also an established culture in the publication environment, which is difficult to fight with. Unfortunately, it exists. We know that we should be aware that those articles that are published, or those research which returns with negative outcome results, which shows no significant differences between the groups, they are usually neglected, and they have less chance of being published. That being aware of that, you can easily say that those millions of articles which are published actually are a little bit biased because they have the positive results. They found some differences. That's why they could publish their results. Those who could not find the significance, they have unfortunately less chance of being published. This is called the newsworthiness or publication bias classical.